Section 5, Video 7, Resource Management of Network. In this video, we'll review how resource management manages networking to enable higher performance and utilization. Network adapters should support following services like checksum offload, TCP, segmentation offload, or large receive offload. These can help improve performance of network and utilization while offloading some of the processing to the CPU. VMware Tools provides VMXNet 3, which is the next generation of high performance network adapters. As always, installing VMware Tools on a newly provisioned virtual machine is best practices, and number of benefits, including the VMXNet 3 network driver. Using network interface card teaming to connect a virtual switch to multiple physical NICs, which helps to increase network bandwidth as well as provide redundancy. For best network performance, it is recommended to use separate physical NICs, and especially for consumers with heavy networking I/O. Identify VMs that interact with each other and move them on the same virtual switch. This will help improve performance as well as reduce the load on the external network, as the communication can stay on the ESXi host on the same virtual switch. Network I/O control, or NetIOC, improves network resource reservation and allocation across this entire switch, and we can select from predefined resource pools including management traffic, fault tolerance traffic, iSCSI, NFS, virtual SAN, vMotion, data protection, and virtual machine traffic to create, or we can create user-defined resource pools. Do note that these are configured similar to the memory and CPU shares, and the virtual machine traffic is given a higher value of shares, 100, as opposed to the other traffic flows which are set to 50. This in a way gives the virtual machine traffic higher priority. The resource management also looks at the load balancing policy, and it determines how network traffic is distributed between the network adapters in a NIC team. When we have a NIC team, the default routing is based on originating virtual port, and the virtual switch simply selects the uplinks based on the virtual machine port IDs that the traffic is entering. And this works, as this is the default setting, this works very well in most of the cases. We also have a route based on source MAC hash, and as the name suggests, the virtual switch selects an uplink for a virtual machine based on the virtual machine MAC address. The virtual switch uses the virtual machine MAC address and the number of uplinks in the NIC team to calculate where to send the traffic out. This is very similar to the route based on originating virtual port ID, as the source MAC hash does not change while the VM is up and running. Route based on IP hash. This is a more complicated version and includes some CPU overhead as well, and the virtual switch selects uplinks for virtual machines based on the calculation of source and destination IP address of each packet that's sent out. One can benefit from the route based on IP hash if the destination is changing, and every time you have a higher utilization of all the uplinks. Finally, we have route based on physical NIC load, which is where the virtual switch checks the actual load of the uplinks and dynamically takes steps to reduce it on overloaded uplinks. This feature, however, is available only with vSphere distributed switch. To summarize, we looked at high performance network adapters like VMXNet 3. We looked at NIC teaming for redundancy and load balancing. We reviewed network IOC and the different types of traffic flows and their share value. And we also looked at network load balancing policies and make a determination of which one to choose best for our use case. In the next video, video 8, we will review resource management from a resource pool perspective. Thank you for watching.